All right, let's talk a little bit about solving simple rational equations. When we solve a simple rational equation, now this is an equation that has fractions in it, although the fractions will be very simple where the denominator is just a number, okay? We're going to talk about a technique that you can use called clearing fractions. This can actually be used for any rational equation that you might find, not just the ones in this section that are real simple. The process for clearing fractions is pretty simple. The first thing that you want to do is look through the entire equation and find the least common denominator for all of the denominators that are in your equation. The second step is to multiply every term in the equation by the least common denominator. What this is going to do for you is allow you to cancel or divide out every denominator that you have within the equation, effectively getting rid or clearing all of your fractions. And once you've cleared the fractions, you can go ahead and solve the equation that's left. Now, for the equations that are in this particular section, what you're going to wind up with here is a simple linear equation where all you'll have to do is just isolate the x. Let's look at an example. All right, in this example, we're going to have x plus 2 over 3 minus x over 2 is equal to 5, 6. So the first thing that you want to do is look at all of those denominators and find the least common denominator. Now, if you just find a regular common denominator, not necessarily the least common denominator, it will still work. You'll have a little bit of extra in your equation that you will have to wind up reducing at the end, but it's okay. It'll still work. So my denominators are 3, 2, and 6. 6 is the smallest number that all of those would go into, so 6 is going to be my least common denominator. And what I'm going to do now is take that and multiply it times each individual fraction, or each individual term, rather. Even if they weren't a fraction, you'd still want to multiply it by the 6. So we get 6 times x plus 2 over 3 minus 6 times x over 2 is equal to 6 times 5 over 6. Okay? All right, now you're going to multiply each one of those through. And what's going to happen here is we're going to be able to cancel, okay? So the 6 and the 3, I can cancel, and that will leave me a 2 where the 6 is. The 6 and the 2 will cancel, leaving me with a 3 there, and these 6's will just cancel completely out, leaving me with a 1 in each place. If you wanted to mark that, you could. So what we wind up with is a 2 times this x plus 2. So I get 2x plus 4. And then 3, or negative 3, really, times x is equal to 5. Now from here we have just a plain linear equation, so what we're going to do next is solve this for x. Combine your two x's that are on the left hand side, and the 2x minus 3x is going to give us a negative x, plus 4 is still there. And then we'll subtract the 4 from both sides here. That'll give me a negative x on the left and 5 minus 4 on the right, which is just a 1. And at the end, you solve by isolating x completely. So we would divide both sides by negative 1 and get x is equal to a negative 1, which you can then check if you like. Okay, so there's one example. People tend to get hung up in this problem in these first couple of steps where they're finding the least common denominator and then using it to multiply through the equation. Most people who get through that part can finish solving the problem pretty easily since they turn into these relatively simple linear equations at that point. Now let's look at a second one, okay? This is a second example. Now this one only has two terms, and I'm going to show you a little trick you can use when you have either one or two fractions, but you only have two terms, one on either side of the equation. You can treat this one as a proportion. And what we can do, instead of literally finding the least common denominator, multiplying both terms by the LCD and canceling, what's going to wind up happening, since there are only two expressions, one on either side, is essentially you're going to wind up multiplying the denominator on one side times the numerator on the other, okay? And that's because if you use the least common denominator, you wind up canceling the denominator that you have in each fraction. So this is called cross multiplying, and you've probably seen it done before. So what we do is we multiply the 3, that's the denominator on the right-hand side, by the x plus 3, that's the numerator on the left. And then we do the denominator on the left times the numerator on the right. This will only work if you have just a single term on either side, a single fraction, or maybe one fraction and one term that's not a fraction, variable or constant, either one. Now from here we would distribute. See, we wind up clearing the fractions very quickly in a problem like this. But we would distribute from here. And then finish solving. So I've got, if I move the 5x over, we can subtract 5x from both sides, and we get negative 2x plus 9 is equal to negative 5. And then if we subtract the 9 from both sides, negative 2x is equal to negative 5 minus 9 would give me negative 14. So x is equal to 7 when I divide both sides by that negative 2. That's the answer there. Okay, so that gives you a couple of good little examples for the linear equations that involve fractions in this section.